Okay, so I wanted to look at section 3.2 and look at an example for finding variance in standard deviation. All right, so remember that we have two different types of problems that you're going to see in this section. So the first type is referred to as raw data, which means that we have the actual numbers in the data set and we're being asked to find variance and standard deviation. So we have an example that has the values 12, 15, 17, 11, 10, 8, and 13. So what I'm going to do is begin by writing my formula down. And let's talk about that formula for just a second. So our formula for variance, remember, is going to be s squared. S squared is the symbol for variance. And then the rest of the formula is going to look like this. So what you want to notice here is that you have to find two sums in order to work the problem. So we're going to start with this sum, which just simply says that we want to take our x values, which are our data values, and we want to add them up. So the easiest way to do this is to set it up sort of in column form. So I'm going to make a column for my x's, and I'm just going to list these values out. And we're going to add them up. And we use our calculator, and that gives me a sum of 86. All right, and so that is going to go in the circled red part in the formula. Now, we also need to find this second sum. So this says that we're going to take our x values, we're going to square them, and then we're going to add them up. So over here, I'm going to make a column for x squared, and I'm going to square each of these values in the first column. So I'm going to say 12 squared is 144. 15 squared is 225. 17 squared is 289. 11 squared is 121. 10 squared is 100. 8 squared is 64. And 13 squared is 169. And we're going to sum that. And that's going to give me the sum of the x squareds. And so we're going to add those numbers up. And that should give you 1,112. Okay, so now we're going to plug into our formula, keeping in mind that the larger sum is always going to go first. So we're going to put in the 1112. We're going to subtract the smaller sum, which is the one I circled in red, at 86. We're going to square that. We're going to divide by the number of values, which for us is 7. And then on the bottom, we're going to divide by n minus 1, which would be 7 minus 1, which would be 6. Okay, when you enter this into your calculator, you need to enter it in one step, and you need to enter in with a parenthesis around the top part of this fraction. So you can go ahead and try it and make sure that you can get it entered in correctly. If you're doing it right, you should be getting 9.24. I'm rounding that to 2 decimal places. And that's going to be your variance. Remember, to find your standard deviation, you're simply going to take the square root. So your standard deviation is going to be 3.04. Okay, so that is our first example. That's an example again where you have the actual numbers given to you and you're being asked to find variance and standard deviation. Okay, so the other type of example that we'll be looking at is a problem where we have a grouped frequency distribution and we want to calculate variance and standard deviation. Now we're going to use the same formula, so we need to come up with the same two sums. So we want to remind ourselves that if we take one of these particular rows, okay, so like this one, we want to remind ourselves that what that tells us is that there were 5 values in the original data set that fell between 15 and 19. Now the problem is that we know that there were 5 values between 15 and 19, but we don't know what those values actually were. And if the first thing I have to do is add up my x values, and yet I don't know what those x values were, I'm going to have a hard time doing that. So the next best thing to knowing the actual numbers is going to be to use an estimation. So what we're going to do is we're going to select a number in that first class between 15 and 19, and we're going to let that number, we're going to let those 5 values be represented by that number. And so we want to think about what value would make sense to select. If we pick the 15, then that's probably not the best choice because some of the numbers are bound to be higher. And if we pick the 19, also probably not a good choice because some of the numbers are actually bound to be lower. So the best choice is to pick the midpoint of the class. So I'm going to add a column here for midpoint, and we're going to go through and calculate those midpoint values. So remember, in the first class we do 15 plus 19, which gives me 34, divided by 2 is 17. All right, and then we can find the other midpoints in a similar fashion. So we have 22, 27, 32, and 37. And so those midpoint values now become our x values. Now remember that there were 5 values between 15 and 19. We're now saying that all 5 of those values were 17. So if we want to add those up, we're essentially saying to ourselves that we want to add up 17 plus 17 plus 17 plus 17 plus 17. And the fastest way to add those 5 numbers up is to use multiplication. So we're going to add a column that says x times the frequency, and we're going to multiply 5 times 17, which gives me 85. 7 times 22, which gives me 154. 3 times 27, which gives me 81. 5 times 32, which gives me 160. And 2 times 37, which gives me 74. And so if we add up this column, this will be the sum of the estimated x values. So we're going to add 85, 154, 81, 160, and 74, which is a total of 554. Okay, so that's one of the sums that we're going to need. All right, the next thing that we need to do is we need to square each of the x values and then add those up. So I'm going to add a column for x squared. And we're going to square the 17, which is 289. We're going to square the 22, which is 484. We're going to square the 27, 729. Square the 32, 1024. And square the 37. So 1369. Now again, remember that these numbers are occurring more than once. It's not that we just have one 289 that we need to add up. We actually have 5 of those. So we finally need to go in and do this last column, x squared times the frequency. Now, this is often a place where students make mistakes, so you want to be careful and be sure that you are multiplying the correct two columns together. So I'm going to do 5 times 289, which gives me 1445. I'm going to do 7 times 484, 3388. I'm going to do 3 times 729, 2187. 5 times 1024, 5120. And 2 times 1369. And then we're going to add up this column, and this will give me the sum of the x squared values. Bringing the total to 14,878. Okay, so now we're ready to use our formula and calculate our variance. All right, so remember that it is the larger sum first. So I'm going to say s squared is equal to 14,878 minus the smaller sum squared divided by the total number of values, which we can get from adding up our frequency column. So that's going to be 22. And then we're going to divide by 1 less on the bottom, so we'll divide by 21. Again, remember that you need the top part of this thing in parentheses as you enter it into your calculator. All right, so let me put it in. Let's see what we get. 14,878. All right, so I get 44.16 if I round up to 2 decimal places. And that's going to be my variance, and my standard deviation will be found by taking the square root of that, which gives me 6.64.